today we're gonna build on our knowledge of circuits and work Ohm's law. Who can remind me what Ohm's law is? Go ahead, Jamila.
The resistance multiplied by the current.
Okay, the voltage is equal to the current times the resistance, or the resistance times the current. And I gave you this little symbol here. So if you want to solve for something, let's say you want to solve for the voltage, you just cover up the V, and that means it's I times R. If you're trying to solve for the current, you cover up the I, and it's V. All right. And if you want to solve for the resistance, you cover up the resistance, and it's V divided by I. So yesterday, when we were working on this worksheet, we should be comfortable figuring out the resistance or the equivalent resistance of these circuits. So we have series circuits, parallel circuits, and then we have some combined circuits where there's series and parallel. So most of you guys already have the equivalent resistance or the total resistance of the circuit. So we're going to use that information to figure out either the current or the voltage on each area of the circuit. So reminder, some information we need to remember about a series circuit. Okay, when we are calculating a series circuit, in case you forget, how do I get the total resistance of a series circuit? Go ahead. All right, so you would do the resistance total equals R1 plus R2 plus dot 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 plus R sub n. So however many resistors there are, you just add them together. And that would give you the total resistance of the circuit. So for example, in this series circuit, it would just be this one plus this one plus this one. Pretty easy. You can see that that's 12. All right. It's a little more tricky for the parallel circuit. The parallel circuit, the equivalent resistance, or the inverse of the equivalent resistance, is 1 over R1 plus 1 over R2 plus dot 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 plus 1 over R sub n. And you have to take the inverse or the reciprocal of the resistance at each resistor, add them together, you will get a number, and that number you then have to take the reciprocal of that. And as you remember yesterday, it worked out better if you just did it in what? Was it easier to do it on a calculator, or was it easy? How? It was easier to do it in your head, but it was easier to do it as a fraction, correct?
Oh, yeah.
Rather than trying to do it on a calculator and do the dot, 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 and the extra numbers and all of that. So if you keep it as a fraction, that is going to be a key to helping you. All right, so on this one, you would take the reciprocal of 2, plus a reciprocal of 4, plus a reciprocal of 6. Lowest common denominator between those numbers is 12. Okay. Add them together, and you get, what, 6 over 12 plus 3 over 12. I think it's, what, 11 over 12, correct? And so then the equivalent resistance is 12 over 11. If you keep it into a fraction, it will help you. Now, what you notice is we have more information we need to solve for. Now, I have a voltage on this battery, so I'm going to use that information and use Ohm's law to solve for the voltage, or excuse me, the current over each resistor here, or on this one, I'm going to solve for the voltage drops at each resistor. So, in a series circuit, the voltage drops across each resistor. Drops across each resistor. The resistors. In a parallel circuit, what changes? So, for example, when I say the voltage drops, what's the total voltage in this circuit? 9 volts. Each resistor will have a different amount of voltage because the key to a series circuit is that the current is the same throughout the line. Okay? So, when I have my voltage and I have my total resistance, can I figure out the current on this line? What would I do to figure out the current on this line? Yeah, take the voltage divided by the resistor. Using that information, now I can go figure out the voltage drop across each resistor. Okay? And that's what you're going to do right here where it says V1, V2, and V3. You'll have a different voltage drop. And I'll come around and make sure you do that. On a parallel circuit, what's the key for a parallel circuit is that what stays constant at each intersection is the voltage. So every pathway, the voltage will remain the same. So the voltage on the path is the same. So that means what changes?
Current.
The current changes, right? So what you're seeing here is you're going to calculate the current across the 2 ohm resistor, the current across the 4 ohm resistor, and the current across the 3 ohm resistor. What do I need to calculate first before I can do that?
The resistance.
Yeah, I'm going to have to calculate the total resistance, which you did yesterday, and we just did. What did we just say it was? 12 over 11. And that will help you, all right? So go ahead and get started. I'm going to come around the tables. You can work together, try to help each other out, and we'll see how we do, okay? And I will start with this table. Yes, that was the, so I'm going to show you. I think it's easier to see it like this. So when you calculated it, it was 1 over R in cubed equals 11 over 12. So how do I solve for this? You have to take the reciprocal. So you take the reciprocal, R in cubed equals 12 over 11. Does that make sense? Is that helpful? So let's look at number 1. What was your total resistance? 12, right? You got 10 plus 2. So your total resistance is 12.
Right.
Where's your total resistance going to go? Yeah. So you already know your total voltage. How do I figure out the current in the circuit? Yep. Yeah. Number one.
Are you asking for this?
Yeah, the total current. How do you find the total current? What's the formula you're going to use?
Ohm's law.
Yeah, how are you going to break Ohm's law up? So what do you want to do if you're finding the current? What do you cover up? Yeah, so you do the voltage over the what?
The resistance.
Yeah. Yeah.
So that's the right here, right?
Yeah, that's the total current in the circuit.
Right. That's 34.
Yeah, you can put it in a fraction. It could be a fraction. It works easier if you do it as a fraction. So now what you're going to solve for is the voltage drop across each resistor. So how do I figure out the voltage drop across each resistor?
We just cover up the resistance to the V and the I.
Yep. And so the resistance changes at each what? Each resistor. So the first resistor has a specific voltage across it. How do I figure that out? No, what is Ohm's law? Okay, let's look at the very first resistor. You got 6 ohms. So now, do I know what the current is?
Doesn't it stay the same?
Yeah, it stays the same. So the current across each resistor is what?
12. No.
The current. What symbolizes the current? What letter symbolizes the current? I. So what's the current across each resistor? 3/4.
Okay.
So what's the resistance there? Well, the resistance at that is 6 ohms. So how do I figure out the voltage drop there? So if I want to figure out the voltage, which one do I cover up? The V.
Yeah.
So what is that? Show me. Yeah, multiply what?
6 times 2.
Yeah, so what do you get? Pretty easy, right?
Yeah.
So what do you get? Tell me what you get.
So what you get?
6 times 3 is 18.
Not so fast. But just use your calculator. I don't know about it.
I'm gonna let you guys work. I'm gonna go check these
Yeah,
out.
we got it.
You think you got that one? All right, let's check this out. Let me see what we got here.
It's 9.
Okay. Do all these add up to 12? Or excuse me, to 9? Yeah, okay, so you're good. So you guys had no problem figuring out for the series circuit the voltage drops. And you kept yours in fractions. Yeah, it works easier than keeping it in fractions. So we're on the parallel circuit over here.
I have a question.
Yeah.
So total voltage is 6, and
Yes.
you get the current, you get the V over R. Is it like 6 divided by 1/6 or 6 divided by 6?
So you have Ohm's law, and right here, so if you have V, so you want to figure out what on this part? The current. So if I cover up the I, what does that tell me I need to do?
Voltage over resistance.
Yeah, so do I know the resistance at each section? What's the voltage at each section? 6. So the current here is what?
6 divided by 6.
Which is,
1.
okay. Does that make it pretty easy to figure out? All right, so what will be the next one?
6 over 4, which is 1.5.
Yeah. All right, so you're good to go, right? Now, when you get to these other ones, I'll come back and check on you. These other ones are you got stuck on the parallel one?
Wait. Are you supposed to divide it?
Well, when you say divide it, what are you
I
talking
meant like
about?
6 over 6 and then
Yeah.
6 over 4.
So yeah, so each section, so we know at each section what is the voltage at each section. No, the voltage is not 2, the voltage is 6. So in a parallel circuit, it's each one has the exact same voltage, and that's whatever the battery is. So each one has a 6 volts. You know the resistance. So how do I figure out the current?
So it'd be
What's the formula?
Voltage divided by the resistance.
Yeah, the voltage by the resistance. Remember, we just cover up the I. That's what I'm solving for. It says V over R. So what's V here? What's the resistance?
6.
So what's the current?
1.
Pretty easy, correct?
We got nothing.
All right,
Is
sure.
the next one 6 divided by 4?
Yes, ma'am.
Okay. And for the other one, so how would we go about that? I'm not
Okay. So let's just take this circuit here first. All right. So this looks like a series circuit here. So what you want to do is have this equivalent resistance here, which you're supposed to calculate there. How do I calculate that equivalent resistance?
Wouldn't it be like the 1/4 of 1/8?
1 over 4 plus 1 over 8.
And then do
Yeah, and then you get the reciprocal of that, and that'll give you the equivalent resistance. That essentially gives you 2 resistors in series. Do you see that?
Yeah.
But each one of these will have a different current, but the current from here and here will be the same. Okay? And that would be the I total.
And what does I mean?
I is the current. So I know it's weird, but that's what the letter is for.
Okay.
Okay. Where are we? Oh, you're eating this up on this. Let's see. Oh, you're pretty far along.
I guess right. This is like how you.
Yeah, so far this is good. What are we doing here on the parallel ones?
We haven't got to this yet. I got
It's going to be the same for all of them.
On the parallel one,
Yeah, for the parallel.
not the current. The current's not the same. What's the same on each one? The voltage, yes.
so it'd be 6 for each of these.
Yep, each one's gonna have the same voltage. So, how do I figure out the current across this resistor?
You do
Voltage divided by resistance.
Yep. So what's that very first one up here? I3. What's I3? 6 divided by 6 volts divided by
5.5. Wait,
no?
6 divided by 6?
Yep.
Oh, so then that's just okay.
That's 1 right there.
So this total for I isn't valid right now. we're just gonna have to add up these once we get there.
Oh, so you can't do this first on the parallel, so you have to do this before.
Yeah.